Good morning, everyone, and welcome to the day 2 of the Climate Risk Summit, which focuses on building resilience to sectoral risks. Well, lots of risks, I suppose, but building resilience. I'm Helen Adams, and I'm head of science engagement in the COP26 for the COP26 presidency, where a lot of our work is actually focusing on risk information. So I was invited to give a few remarks as we go into day 2 and start looking at infrastructure resilience and health and communicating uncertainty. For us as a presidency for COP26, one of our priorities is to ensure that academic information, science in its widest sense, writ large, supports policy making. We want all the decisions that come out of COP26 to be based on the best available science, and the UNFCCC draws on the IPCC. We want all the positions that the UK takes in negotiations to be based on science, drawing on our own climate change committee and our climate change risk assessment, but also the global assessments such as the IPCC reports and Working Group 2 assessments. But we're also looking to ensure that where we can, more generally, we shorten the distance or ease the communication between academic worlds and policymakers, on the acknowledgement that there is still that barrier between the people who have the information, who understand the urgency with which we have to act, who have data and knowledge on that, but aren't able to feed that into the people who need to hear it, or the people who need to hear it aren't interested. And how do we pique their interest? How do we deliver this information in a way that policymakers across different sectors and leaders see that this is something that they must be interested in and can't ignore? So I just want to flag that. So this workshop is really important because we're looking at the way science can support high ambition for COP in 3 sectors or 3 areas. One is on the way in which we can highlight co-benefits, so things like the health benefits of ambitious climate action. Another is on the solutions and visioning futures that we want, the positive, encouraging and building positive ideas of a greener and more equitable future. And then the final one is, how do we better deliver risk information so that people are aware of the risks that can't be avoided due to climate change, but also the risks we have time to avoid through strong mitigation action. So all that's to say that this workshop is really timely and really important. I'll stop there, but I think I really look forward to hearing what comes out of the workshops and thinking forward, as we move into the final weeks to COP, how we can use some of those outcomes to continue to apply pressure on the policymakers around us to ensure that we have an ambitious outcome for COP and we keep the 1.5 temperature rise target alive. Thank you very much, and I wish you some good sessions today.
Good morning, good afternoon, or good evening. A warm welcome, everyone, and thank you for joining this panel session on compound dry hot extreme events, enablers and barriers to individual and community preparedness and response. I'm glad to see such a great audience, and for those who are joining, I would like to say a little bit about me. My name is Raquel Nunes, and I'm the session organizer and chair. I'm a senior research fellow in public health and environmental social science, based at Warwick Medical School at the University of Warwick in the United Kingdom. My research has been primarily on vulnerability, resilience, and adaptation to extreme temperature events and the links between health and sustainable development, but my interests now also include compound dry hot extreme events. So let me start by briefly take the time to introduce why the topic of this session is important. First, we know that global climate change affects us all, but some more than others. It acts as a health risk amplifier to increase inequalities. The impacts of extreme events depend on vulnerability, resilience, and adaptation of the individuals and communities affected. Secondly, according to the IPCC's Working Group 1/6th Assessment Report, compound extreme events are the combination of multiple drivers and/or hazards and contribute to societal or environmental risk. Examples are concurrent heatwaves, droughts, and compound fire weather conditions, or concurrent extremes at different locations. Additionally, there is high confidence that concurrent heatwaves and droughts have become more frequent over the last century, and this trend will continue with higher global warming, according to the IPCC. Thirdly, if we consider that individually occurring extreme events already produce serious impacts, it can only be expected that compound extreme events are associated with more damaging effects. Fourthly, according to the principles of the Sendai framework, effective disaster risk reduction depends on the mapping of risks and risk-informed strategies for both the prevention of disasters and reduction of impacts when they occur. And finally, it is crucial that we know who the most vulnerable are, where, when, and how they are most vulnerable. So in the next slide, this is why during this session we will talk about this topic. And the session objectives, in the session objectives, we want to give you some clear examples and discuss the need for preparedness and response, not only to reduce vulnerability, but also to build resilience and improve adaptation, and how this can be achieved. And this is what we really want to discuss today. We will share evidence and experience about compound dry extreme events. The session will also focus on activities, programs, and measures that can be implemented before and during a compound dry hot extreme event to reduce impacts, drawing on worldwide experience, learning, and best practice. So the main objective of this session is to discuss what needs to be done for individuals and communities to better prepare and respond. It will build on speakers and audience expertise, perspectives, and lived experiences. So this is what we want to do. Our expectation is that this will lead to a broadened discussion of what needs to happen with your help. So please engage as much as you can throughout this session. So in saying this, in the next slide, let me now tell you that the session will also deliver an interactive discussion and will be taking time to create a space for sharing ideas. So I would like also to give you a little bit of housekeeping. So down on this page, you can see a Slido survey and a Q&A box. So I invite you to participate and would really encourage everyone to answer our Slido questions. And we're going to reflect on this later in the session. We have an extraordinary group of international speakers who will talk to us about preparedness and response, what is being done, what more is needed, and ultimately to offer us a roadmap to achieve reduced impacts. And now, without further ado, it is my great honor to introduce our first speaker, who is joining us by video presentation. She is Kristie Ebi, a professor of global health at the Center for Health and the Global Environment, part of the Department of Global Health at the University of Washington in the United States of America. And I'm very pleased that she was able to present today. She has been conducting research and practice on the health risks of climate variability and climate change for nearly 25 years, focusing on understanding the sources of vulnerability, estimating current impacts and future health risks, designing adaptation policies and measures to reduce the risks of climate change in multi-stressor environments, and estimating the health co-benefits of mitigation policies. Kris has supported multiple countries in Central America, Europe, Africa, Asia, and the Pacific in assessing their vulnerability and implementing adaptation measures. And I personally have learned a lot through the work she does, and I'm really excited to invite Kris to help us understand a little bit more about the impacts of compound dry hot extreme events on human health, and to better understand human vulnerability, the need for adaptation efforts, and how to protect and promote human health. Kris, the floor is yours.
Hello, I'm Kristie Ebi. I'm a professor in the Center for Health and the Global Environment at the University of Washington. I'll spend the next few minutes talking about protecting and promoting human health from compound dry heat extreme events. I'll focus mostly, but not exclusively, on heat extremes. The graphic on the left shows what happens when we're exposed to higher temperatures, and our normal physiological mechanisms are insufficient to manage those higher temperatures. Our normal mechanisms include things like sweating. We can also do things like go sit in a cooler environment, sit in front of a fan, for example. And when our normal physiological mechanisms and the actions we take are insufficient, then our core body temperature can start to rise. And as that core body temperature starts to rise, our cells and our organs start to heat up. Our cells and our organs operate within a really narrow range physiologically. And once they get hotter than that range, there's a lot of strain put on key organs, such as our heart. And so as our temperature increases internally, if there are no interventions, then people can start experiencing heat stress, can go on to heat strain. Some people can have heat stroke. After an extreme weather or climate event, and one collects all of the data from death certificates, typically about half of the deaths in a heat wave, the excess deaths in a heat wave, are from heart disease. So that additional strain on our organs can cause a death that would not have occurred otherwise. A key conclusion is that almost all heat-related deaths are preventable. That as we look at the numbers of people who die in heat waves, think about all those deaths that could be prevented, and people could go on and continue to live their lives. It's not just morbidity and mortality. There's other heat-related effects, such as on occupational health and productivity, increased injuries and illnesses in sports. We know that pregnant women, for example, are at increased risk during heat waves for having babies that are born too early, babies that are born too small. A wide range of consequences of higher temperatures. The physiological limits of heat are finite. There's only so much temperature our bodies can adjust to. But lots of factors determine those limits. It's not just the temperature itself. So thinking about overall heat tolerance, we have to look at a range of other factors. All of this is important because climate change will continue to increase morbidity and mortality without urgent and immediate investments in research and risk management. A heat dome settled over part of the Pacific Northwest of the United States and Canada at the end of June of this year. And the map shows you the three main cities, Portland, Seattle, and Vancouver, that were affected. The whole region was affected. A lot of the research has been done on those three cities. You can see how high the temperatures were relative to previous records. Those are in degrees Fahrenheit, in degrees Celsius. Many parts of these regions saw temperatures that were 5 degrees Celsius over the previous record. This heat wave was virtually impossible to have occurred without climate change. Across the 2 states in the United States and in British Columbia in Canada, there was about 1,000 excess deaths, 1,000 people who would not have died during that time period. There was a very large spike in visits to emergency departments. During the 5 days, the 25th to the 30th of June, emergency department visits were 69 times higher than normal. This is all within the context that July, the next month, was the Earth's hottest month on record. And you can see how high the temperatures were just in the northern hemisphere. For the land surface, the temperature was more than 1.5 degrees Celsius above average. A recent study looked at heat-related mortality over about the last 20 years to look at what proportion of that mortality could be attributable to climate change. Overall, across the world, acknowledging that many parts of the world, particularly Africa, have very little data, about 37% of all heat-related deaths that occurred over the last couple of decades are due to climate change. You can see variability across the countries with higher attribution in parts of the global south. Much more information is needed to be able to understand the risks in countries that were not covered. And there's a lot more that needs to be understood in how we can help prevent these excess deaths that are occurring. As you likely saw in the release of the Working Group 1 report to the Intergovernmental Panel on Climate Change 6 Assessment Cycle, extremes are projected to increase in frequency and intensity with every additional increment of warming. This shows just the hot temperature extremes over land. On the left are 10-year events. On the right are 50-year events for a baseline of 1850 to 1900. On the right-hand side, you can see that a once in 50-year event by today is now almost 5 times more likely to occur. With additional warming to 1.5 degrees, it's over 8.5 times more likely. 2 degrees, almost 14 times more likely. The heat dome that affected the Pacific Northwest and Canada was rarer than a 1 in 150-year event. So it was much more extreme than what's shown on this slide. And as we go forward, the projections are we're going to continue to see these very extreme extremes, which will be associated with increased morbidity and mortality unless additional actions are taken. These projections are just for the United States, looking at annual heat-related deaths in the US. The baseline is about 12,000 Americans die every year from heat-related causes. And when you look at these figures, the top row is with adaptation to changing temperatures. The bottom row is no adaptation. The columns are business as usual, which is RCP 8.5, modest emissions, and then aggressive emission reductions for RCP 2.6. And you can see under all of these different sets of projections that by the end of the century, there is going to be an increase in heat-related mortality unless additional action is taken over above the assumptions here for adaptation and over and above what's done to reduce our greenhouse gas emissions. We certainly don't want to be on the bottom left, business as usual, no adaptation, showing a huge increase in mortality. And again, this is preventable, which is why we need to very urgently implement heat action plans, which I'll talk about in a moment. And it's not just the heat, particularly in the Pacific Northwest and western parts of Canada, it's also the wildfires. You can see on the left, in hotter years, there's a higher wildfire risk in the western states. I'll note that only goes into 2019, so hasn't shown the significant wildfires in 2020 and in 2021. On the right shows you that the particulate matter that is associated with wildfires, PM 2.5, is associated with risk for diabetes, lung disease, and heart disease. The air quality index across the bottom shows good, moderate. The middle category is for particularly susceptible groups, and then above about 60 micrograms per cubic meter of PM 2.5 is unhealthy for everyone to breathe. In my community, where I live in Seattle, a couple of years ago when we had significant wildfire smoke coming into the region, my neighborhood had an air quality index of about 250. A community outside of Los Angeles, where there's been very significant wildfires over the last month, had air quality index measurements of over 750. The exposures are extremely high, and we know that they cause adverse health outcomes. And so thinking about how we manage both heat and wildfires is important for health. For heat, there are hundreds of heat wave early warning systems around the world. I'm going to highlight one from England, was put together by Public Health England. It comes out on an annual basis, and you can see on the right the core elements. There is an extensive engagement with service providers, with the community, with everyone who could be affected by or who provides services for people affected by heat. You can see the levels of the alert on the bottom. There's all-year planning. There are specific preparedness programs set in place for the summer season, including making sure that people are prepared for heat waves should they occur, making sure the communication plans are in place. These are developed with communities to make sure that they will be as effective as possible. And then you can see there is forecast, actual action, and then a major incident. And for each one of these, there are activities organized and responsibilities assigned to different service providers to ensure that there is a comprehensive response to the heat wave. As the Pacific Northwest is developing its own heat action plans comparable to this, it will focus not just on heat, but also on wildfires, because of course we experience heat and wildfires simultaneously. This shows for the heat wave plan for England the cascade of heat wave alerts. I'm not going to go through this, but it is to highlight the wide range of services that are engaged. Everything from nurseries and kindergartners to ambulance trusts to make sure that everybody's on board with what needs to be done when there is a heat wave. This figure shows you just for commissioners of heat and social care and for local health authorities what is done during each of the levels of this heat action plan. The heat action plan goes through for all of the providers what each are responsible for. And it's a very nice example to look at to have ideas of what can be done in your country, in your region. With communication, there's lots of efforts that have been done to find ways to effectively communicate, effectively motivate people to make change when it's hot out. You can see on the left the poster from Quebec showing some kinds of actions that need to be taken when the temperatures are really high. And on the right is an effort underway in Canada to develop a nationwide heat wave early warning system, taking into account the different climate zones and taking into account actions that have already been taken in some regions, and also considering things like warning fatigue. On the left shows a wide range of activities individuals can undertake to stay cool during the heat. Using electric fans, making sure that you do things like wet your skin in front of a fan so that you've got greater evaporation. And as you look at these, you'll note that none of them involves air conditioning. In most parts of the world, it is possible to stay cool during a heat wave without having to have air conditioning. There are some places where air conditioning is necessary. It's not necessary everywhere. On the right-hand side shows you different settings, individual level strategies in those settings. And equally important underneath that is when we think about how we're going to prepare for a very different kind of future, we need to think about building level and urban level strategies. Heat action plans look into the future and think about how we're going to be modifying our infrastructure, planting more trees, requiring white roofs or green roofs, looking at different kinds of construction materials to start building that into our planning at the community level so that as buildings are modified, we start taking into account our future is going to be hotter and we need to be better prepared for that to protect and promote human health and well-being. In conclusion, heat is an all-of-society problem. I focused, of course, on the health aspects. There's also impacts on agriculture. In the heat dome in the Pacific Northwest, there was about 1 billion mussels and clams that were cooked as the temperature in the ocean heated up with the heat wave. And that affects food security for tribes. It affects a whole range of other important activities for livelihoods, for well-being across the region. And so thinking about how to be better prepared for a much warmer climate, we need to take all of these into account and look into the short-term immediate actions we need to implement and the longer-term changes in our community structure, our urban planning, to make sure we're prepared for that future that is coming at us. Thank you very much for listening, and I hope the meeting goes very well.
I would like to thank Chris for this amazing presentation. He made it really clear the importance of compound dry hot extreme events and the need for early warning systems to better prepare and respond to such events. I'm really grateful to have everyone here with us today, and I'm going to ask everyone to continue to input your answers down on this page into our slide survey as well as the Q&A box, so we can have a greater discussion later. Now I'm very pleased and would like to introduce our second speaker, joining us now by video presentation, but who will join us live for our discussion later. He is Samuel Sutanto, a researcher from the Department of Environmental Sciences at Wageningen University in the Netherlands. He's an expert in climate change, drought, weather forecasting, climate adaptation, and climate services, and has comprehensive knowledge of hydrology, natural hazards, and atmospheric physics and chemistry. He has been developing seasonal drought forecasting algorithms, contributing to the prediction of compound and cascading hazards, and interacting with end users to improve drought forecasting skills. I would like to invite Samuel to talk to us about exploring and mapping compound dry hot extreme events to understand the vulnerability and increase the resilience of people and places for better adaptation and reducing impacts. The floor is yours, Samuel.
Good afternoon, everyone. My name is Samuel Sutanto, and thank you for inviting me to present my works here. Today, I will give a presentation about reducing the impacts of compound and cascading dry hazards, namely drought, heatwave, and fire. I would like also to acknowledge my main collaborators, Claudia Vitolo, Claudia Di Napoli, Henny van Lanen, and Frederick Wetterhall. This slide shows the impact of natural hazards to humans from year 2008 to 2017. If we look at the number of affected people, then drought is the number one hazard that affects around 73.9 million people, followed by floods, 73.1 million, and after that storm, 33.9 million people. Heatwave and fire only count for 9 and 0.1 million people respectively. The highest impact is found in the least developed country. In terms of economic losses, more than 100 billion euro lost due to drought in the past 30 years in Europe. Please remember, this number is not including the drought in 2018. In the US, around 2.2 billion US dollar lost during 2014 California drought. And just for agriculture drought in the Netherlands, around 820 million up to 1.4 billion euro lost during drought events in 2018-2019. This figure below, taken from the Food Agriculture Organization, shows the top 10 disasters causing greatest damage to agriculture, and drought contribute to 10.5 billion US dollar. The impact from natural hazards singly will be higher if there is an occurrence of compound and a cascading hazard. An example can be seen in this figure. This figure shows the drought index derived from the precipitation data, namely standardized precipitation index. If we look at this figure, we can notice that droughts in 1976 and drought in 1996 had higher severity than drought in 2003. However, combined with heatwaves and fires, the hazard event in 2003 was one of the most fatal and costly, with more than 70,000 people passed away and economic loss accounted for more than 8.7 billion euro. Despite the high impacts from compound and cascading hazards, most of studies that have been carried out treat dry hazards as a single hazard. In fact, all these three dry hazards, drought, heatwave, and fire, are interrelated. For example, drought triggers and increases the probability of heat wave, and vice versa, heat wave triggers and increases the probability of drought. On the other hand, drought only increases the probability of fire, and fire does not trigger and increase the probability of drought, at least for short term. Meanwhile, heat wave increases the probability of fire, and fire triggers and increases the probability of heat wave. Because of this, we need to always consider the occurrences of compound and cascading events and not only single hazard alone. And most studies only deal with a single hazard due to the challenges of analyzing a multi-hazard framework. The figures below show the number of compound and cascading dry hazard occurrences and the durations of compound and cascading dry hazard from 1990 to 2018 based on the reanalysis data. The drought was identified using soil moisture data, the heat wave was identified using temperature data, and fire was identified based on the fire weather index approach. If we look at only the number of compound and cascading dry hazard events, then West, Central, and East Europe are regions that are prone to compound and cascading dry hazards. However, in terms of duration, southern European countries such as Portugal, Spain, Italy, and Greece are prone to long compound and cascading dry hazard events. The next figure here summarizes the percentage of area in Europe that was affected by single and compound hazards. Drought is the hazard that affects most of the European countries, followed by fires, compound drought and fires, and heat waves. One should note that all the data here were generated from the reanalysis products and not based on the real observed event. Up to this slide, I discussed with you the impacts of dry hazards and the importance of considering the compound and cascading events. Then, what can be done to reduce the impact of the compound and cascading hazards since the occurrences of dry hazards will be higher in the future due to climate change? There are many ways to reduce the impacts of natural hazard. And starting from this slide onward, I will discuss with you some examples that have been done in our project to reduce the impacts of dry hazards by promoting early detection of hazard and possible impact occurrences through early warning system forecasting and providing climate services to end user. And this is in line with one of the Sendai's disaster risk reduction global targets, which is availability and access to multi-hazard early warning systems and disaster risk information and assessment. And this slide shows the Anywhere multi-hazard early warning system platform. The Anywhere multi-hazard early warning system provides information on the occurrences of many weather-related hazards from 1 to 7 days ahead for flood, storm, wind, and heat wave, for example, and up to 7 months ahead for drought. However, the Anywhere multi-hazard early warning system does not show the occurrences of compound and a cascading event. This can be done just by overlapping the hazard maps in the Anywhere early warning system. And here the figure on the left shows an example of the forecasted heat and fire as single hazard and as the compound hazard using ECMWF 10 days forecast issued on 17 June 2017. And from this figure, we can notice that fire, heat wave, and compound fire and heat wave were forecasted to occur in Portugal, Spain, and to some extent in France and Italy. But if we look into more detail in Portugal that was hit by severe fire and heat wave in June 2017, the compound of heat wave and fire that struck Portugal can be predicted using forecasts initiated on 7 June 2017 or 10 days ahead. If you look at the right figure over here and the red line, we see that with using the forecast initiated in 7 June 2017, basically we can predict that more than 50% the area in Portugal will be hit by the compound fires and a heat wave. And this study, however, is still an experimental phase, and some works need to be done to implement this method to operational early warning system. Next is another example on how the impacts of drought can be forecasted using the random forest approach by linking seasonal drought forecasts with drought impact database. This example shows forecasted drought impact on water quality, freshwater ecosystem, and terrestrial ecosystem in Brandenburg, Germany. All the blue lines in this figure show the forecasted likelihood of impact occurrence using reforecast data initiated every month for 7 months ahead from year 2002 to 2012. Now let's look in detail drought event in year 2003, shown by this rectangular red color over here, and drought in 2006. The right figures show how the drought impact model can forecast the drought impact in year 2003 and 2006. For 2003 drought, the top figures, the impacts can be predicted 2 months in advance. This is shown by the blue and purple color. While for 2006 drought, the impact can be predicted even up to 6 months in advance. This is shown by the yellow color over here. Again, this work is still in an experimental phase. Some work needs to be done to implement this method to operational early warning system and to forecast the impacts caused by the compound event. This slide shows the water apps that has been developed for farmers in Ghana and Bangladesh. Using this interactive app, the farmer can input the forecast data based on the indigenous local knowledge. For example, the occurrences of some animals, here for example like an insect, bird, and also the occurrence of weather phenomena related to extreme weather events. For example, like a strong wind from a certain region, if there is a red circle around the sun. And the farmers can also get information for the scientific forecast for 1, 7, and 14 days ahead. And later, we extend it to seasonal forecasts for better agriculture planning. This slide shows that we also train the farmers on how to interpret and use the mobile apps by creating forum group discussions. The aims of the FGD are, first, to build the farmers' capacity toward weather, water, and climate events that will increase the community resilience. And the second, build the farmers' capacity towards information and communication technology and the use of mobile app. And third, co-develop water climate agricultural advisory services. Based on the information from the app, the farmers can adapt their planning and possible extreme weather events that may occur in the coming weeks and months. From this slide onwards, I will show you how the forecasted reservoir volume can help to reduce the impact of dry hazards in Catalonia and some examples of the adaptation strategies applied during drought event. The red, orange, and yellow areas indicate the reservoir volume in the emergency, exceptional, and alert situation, respectively. The last reservoir volume was observed in May 2017, and the forecast showed that the reservoir volume will decrease in the coming month. This is shown by the dashed lines. Lately, in November 2017, indeed the reservoir volume was near to the alert situation, close to the minimum forecasted volume. And then, what adaptation strategies can be performed when we are at the alert situations? During normal conditions, the water in the reservoir can be used up to 60%. During alert conditions, the water in the reservoir can be used up to 40%, and the rest are from groundwater, desalination, and reused water. During emergency, only 20% water in the reservoir can be used. The right figures show the municipality supplies in average for citizens and industry in Barcelona. During alert, maximum 250 liters per day is provided, but during the emergency situations, only 200 liters per day water are provided, and it decreases to 160 liters per day when they have emergency phase 3. These are other examples of adaptation strategies that are planned to cope with drought situation in Catalonia. During alert situations, irrigation can be carried out only in the evening to reduce the losses of water due to evapotranspiration with maximum 450 meter cubic water per hectare per month. For private watering, for example for your garden, it is allowed only 2 days a week. Giving water to plants are prohibited during the emergency situations. And during these emergency situations, cleaning streets, pavements, and facades for private purposes is prohibited. This can only be done if there is a health or road safety risk or an accident. For cleaning vehicle, it is allowed only for commercial vehicles such as food transport and ambulance. For private car, cleaning is allowed only to clean the glasses, light, and mirror. These all are applied for all conditions from arrest to emergency. To end my presentation, there are 5 messages that can be derived from my talks. First, we need to focus more to the occurrence of compound and cascading hazard instead of only single hazard, since compound and cascading hazard trigger higher impacts. Second, multi-hazard early warning system including research to predict compound and cascading events exists, but some work needs to be done to implement this in the operational mode. Third, hazard impact, remember not indices, can be predicted well in advance, but no study predicts the impact of compound and cascading hazards yet due to the missing knowledge in predicting the impact of compound and cascading hazards. Fourth, water up and forum group discussion have been implemented in Ghana and Bangladesh, and this can also be implemented in other regions. And this activity helps the farmer to increase the awareness and adaptation strategies on the upcoming extreme weather events. Last, with advanced information on the occurrences of dry hazards, including their possible compound nature, some adaptation strategies can be well planned. And with this slide, I would like to say thank you for your invitation and for your attention. And a detail of this talk you can see from the study stated below.
Thank you so much, Samuel. Thank you for putting into context and provide us with a view for the identification of hotspots and the assessment of hazard patterns that can be useful to determine relationships among extreme events. I would like to remind those who have joined us a bit late that you can participate in this session by sharing your experiences and scrolling down on this page and inputting your questions into the Q&A box, as well as your answers into the Slido survey, so we can have a good discussion later. I would now like to invite and introduce Andrew Kruczkiewicz, a Senior Staff Associate at the Environmental Monitoring Program and Disasters Team from the International Research Institute for Climate and Society, part of Columbia Climate School at Columbia University in the United States of America. He works in the intersection of the social and physical sciences, especially the integration of remote sensing in early warning systems for extreme events, such as wildfires, to inform preparedness actions and risk assessment within the humanitarian sector. Andrew specializes in remote sensing and mapping of atmospheric and meteorological variables. His work also explores how to best communicate uncertainty found within climate and weather impact-based projections and forecasts to decision makers in the humanitarian sector at subnational, national, and global scales. I'm really excited to hear about compound risks and complex emergencies and the need for new approaches to preparedness. Andrew, I invite you to our session and thank you so much for being with us live.
Hello, thank you for the introduction. I'm very glad to be here today, joining live from New York City. Thank you to the organizers for the invitation and for facilitating such a valuable session today. I'm honored to follow the speakers and be in the session with everyone today to discuss this topic. And today I will talk about a few aspects, building off some of what was already discussed, but then focusing at the end about trends and opportunities to move forward to better understand risk of dry hot compound events, and specifically, how do we move from availability of risk data to anticipatory action and preparedness to better decrease the risk, in particular on vulnerable populations. So as Raquel has mentioned, I'm Andrew Kruczkiewicz, calling from New York. I also have a position with the Red Crescent Climate Center as Science Advisor. Today's talk, I will be discussing the intersection of the physical sciences and the humanitarian space when we're talking about, how do we understand risk of these sorts of events? What are the policy implications, and how do we develop action plans to do something about it in a collaborative way? Next slide, please. Today's talk will be talking about anticipatory action. So yes, moving from availability of data, moving from early warning systems to actually taking action in a structured, sustainable way. We'll be talking about timescales, understanding of risk, and then prioritization of action. We will be talking a little bit about a couple of case studies today. Western United States. This is something that was mentioned earlier in the session, but I will present some different framing here, talking about the shocks and the stressors. When we have these types of dry, hot extremes, how do we identify which is the shock? Talking about the attribution study of a heat wave in East Africa, where it was a dry, hot event, and we're trying to disentangle the relationship to climate change to better understand, yes, what can we expect in the future. Then after that, we'll be talking about the path ahead for a compound event anticipatory action. Talking a little bit about the constraints. I thought that'd be good to put in there. Why haven't we had success, large-scale success on compound event anticipatory action? Trends, and then climate services for compound events. What does that mean to engage with the national meteorological and hydrological services to produce actionable information for people to understand risk and then do something about it? Okay, next slide, please. So I wanted to start with this picture. And this is my city. This is New York. I'm from New York as well. And maybe there's some in the audience saying, okay, great, you're showing me a picture of a smoggy city. What is so special about this? And you'd be right. New York doesn't necessarily have the best air quality, but it's also not the worst. Go back, please. There you go. And yeah, you'd be right. But these are pictures that were taken earlier this year when New York City felt the effects from the wildfires happening out west. And this was an eye-opening situation for many here to see the connection, the teleconnection in some ways that New York has directly to the events happening out west. It was a wake-up call. It was a teachable moment to talk about the connectivity of climate and extreme weather events. But it really wasn't until, if you go to the next slide now, please, it wasn't until this that people really woke up and were having discussions about what was happening. This is a picture of the sunset, and it doesn't usually look like this, but this red sun filtered out by the smoke and creating this scene that many haven't west, and why it matters in different parts of the country. This also led to discussions of what do we do about it and what are the effects. Many people think like, oh, well, things are happening out west, it doesn't impact here. But from an air quality and health perspective, it was impacting life all the way over here in New York, and people started asking, what does this mean in the future? Next slide, please. So what was happening out west? This is a map of drought conditions, and we see, the darker reds out west in California and the Pacific Northwest indicate more intense drought. Next slide. And just for reference, we have New York City here, so it's in the clear. And this made me think a lot about the services related to dry, hot extremes. What are the products? What is the risk information being communicated? And when we're talking about people being impacted by these, what does that mean? Is it fair to have no color, essentially, over places of large parts of the country to show no impact? Clearly, the intensity of the impacts in the West are higher, and that's what's indicated here. But what about impacts in other places, in different spatial scales, and different temporal scales? And why does this matter when we're talking about what anticipatory action should be taken by whom, who is accountable, and who is responsible to take those actions? But again, this is not heat here necessarily. Okay, maybe indirectly, this is indicative of heat. But if we go to the next slide, we could see the story is a bit more complex. So this map here is the temperature anomalies for the same period. So this is the deviation from normal, and the blues is where we were seeing below average temperatures, and then the kind of browns into reds, we are seeing increasingly strong temperatures. And this was also mentioned earlier in in the session as well in the Pacific Northwest case study. Well, we should see. Hold on, I'm trying. Is it possible to move to the next slide? There we go. Thank you. We could see that in some areas we do see this overlap. In the same locations at the same time, we are seeing dry and hot conditions. And I will not go into this because it was unpacked earlier on in the session. And yes, there are clear impacts from that. But it's not so easy if we're thinking about using the drought map on the left to prioritize action and incentivize, encourage people to take action and better prepare. That's a large area over the Western United States to influence the way of people's daily lives. And if we go to the next slide, we will see there are some areas that will not necessarily see that compound dry-hot signal. So what does it mean to prioritize one area and deprioritize another? What are we incentivizing people to do or not do? And these are key elements of understanding the level of risk, the evolution of risk over a period of time, and also thinking about what is the responsibility of local government, national governments, and also personal responsibility to better understand the relationship of dry and hot compound events, and also dry and, let's say, non-hot or less hot compound events, and thinking about what we will do the next time we will be faced with this risk, because it will happen again and again, and likely in increasing frequency. Next slide, please. So enter anticipatory action. This is a mechanism that the humanitarian sector is championing over the past few years to move from availability of early warning information to structured action. What I mean by structured action is not just having alerts on your phone when there might be a flood, but having a system in place with So right here, we see this is the traditional humanitarian approach. We have a risk of disaster increasing, preparedness measures implemented, disaster impact occurs, livelihoods impacted, funds are allocated afterwards, and we have emergency response. This is the process that has been happening for many years, especially in the humanitarian sector. However, the Red Cross and others, such as World Food Program, such as the START Network, and other organizations are pivoting this to a new normal. If you go to the next slide, and that new normal focuses on, yes, monitoring early warning systems, understanding risk of disaster when it's increasing, developing triggers, predefined triggers before we see an increased risk of an event, and then funds released before a disaster occurs. This is the big change, and we have examples of this working for various events. For floods, for riverine floods, I should say, tropical cyclones, cold waves, and heat waves. And if we go to the next slide, we will see forecast-based financing, which is the Red Cross version of anticipatory action. So anticipatory action is the broader space of moving from early warning information, risk information, to taking action in a structured approach way. Forecast-based financing is the Red Cross version of that, let's say, where we enable access to humanitarian funding for early action with the goal of anticipating disasters, preventing impact, and reduce human suffering, in particular in the most vulnerable. So if you go to the next slide, these are the main elements: triggers, early actions, and financing mechanism that really facilitate that pivot from mostly reactive to mostly proactive, obviously not mutually exclusive there. And if we go to the next slide, we will see where on a global scale we have been successful in implementing early action information down into standard operating procedures. Who does what? Where does the money come from? And what do we expect in terms of decreasing impact from disasters? Now, there's examples from different parts of the world here. However, we have not developed many of these for compound events, and we have not developed anything for compound dry heat events. So it is an opportunity to discuss that, and I wanted to make sure that part of my time here was identifying this opportunity and almost a call to action to think about what would those early action protocols look like? What does anticipatory action look like for compound dry hot events? And this is an ongoing discussion that we are currently thinking a lot about. Next slide, please. Next slide, if possible. Okay, maybe the next slide isn't working. All right, well, the next slide, I believe I was planning to discuss some of the attribution work. There has been a lot of efforts recently to attribute heat waves to climate change and also other extreme weather events to climate change. I also believe this was in a session yesterday talking about the attribution. There is a group called World Weather Attribution, which Red Cross is a part of, also with Freddie Otto, who I believe was speaking yesterday. And the 2016 to 2017 drought in Kenya, there was an evaluation study done. Here it is, I believe. I'm not sure if it's on the main screen yet. I believe it is. Yes, but the story was, yes, the drought was heat waves that occurred at the same time as the drought. And this allowed for us, I think it's up now. So this allowed for us to start to ask some questions about why is it important to understand attribution analysis in a compound event perspective? What are the statements that we could make about each individual hazard in terms of increased likelihood due to climate change? And then also, what is the importance of understanding the combination of the two? What data is best to use to understand the co-occurrence of these two events? Okay, next slide, please. Yeah, and this is these are the temperature anomalies on the left and the precipitation on the right for Northwest Kenya, but I think we should move through this to get to the conclusions due to the technical glitch. So if we go to the next slide, please. Yes, so the key findings. So the trends indicated that temperatures are hotter than they would have been. However, more work needs to be done. And then more broadly, on the context of understanding increasing risk, there's a few recent papers I would like to highlight here. Such events may become especially severe in water-limited regions, and thinking about how social inequalities heighten the risk and magnitude of compound disasters, and impacting the very communities that are least equipped to handle them. So there is more work coming out on this, but we do need need more efforts to understand the way forward here. Next slide, please. So I wanted to end here and talk a little bit about the constraints to heat wave and dry spell anticipatory action. Why haven't we done this yet? And here are some constraints / opportunities to move forward. One, quantifying uncertainty. This is a challenge in any context of understanding risk and developing anticipatory action programs, but is something that and temporal constraints of the compound event, and how does that definition fit into anticipatory action programming? Integration of relative contributions. So yes, building off that, how do we address relationships of each and combinations of both? There's some new work coming out on this, which is exciting, looking more at the large-scale teleconnections around the relative contributions of the individual hazards. Communicating uncertainty. So I thought it was important to note this. And in my career, I've begun to work more with visualization experts, cognitive scientists as well, to understand methods to communicate multiple hazards and their uncertainties. We have a paper out recently that may be of interest on that. And then prioritizing actions. How do we know when and where to prioritize? Also, flipping that around, that is also a question to be asked in a different way: when and where to deprioritize? Who's accountable for that deprioritization? And then how do we understand if we're specifically designing actions to decrease disproportionate impacts on the traditionally underserved? I mean, I think from my own perspective, I'm extremely privileged to discuss risk in this way. And I think normalizing discussions around disproportionality of impact and making that a focal point of the actions that we take in designing these policies and programs, I think is an important part that should remain central to the way forward. So thank you very much to the organizers. I'm very much looking forward to the questions from the participants later. Thank you.
Thank you so much, Andrew, for your insightful presentation. You made it very clear that we really need to be using a multi-hazards approach to reduce risks from compound dry hot extreme events and to better communicate about compound risks, and also bringing together diverse stakeholders to the table as we're doing in this session. So I would like to continue reminding the audience that you can participate in this session by sharing your experiences, scrolling down on this page and inputting your questions into the Q&A box, as well as your answers into the Slido, so we can have a discussion later. Now I'm really pleased and fortunate to introduce our last speaker, Ross Thompson, an environmental public health scientist within the Extreme Events and Health Protection team at the Public Health England in the United Kingdom. Ross has extensive experience in the operational aspects of responding to heat waves, cold weather and flooding. Ross's focus within the team has been on monitoring of the observed health impact associated with extreme weather in England, and also working in collaboration with the Met Office to improve the current alerting systems for hot and cold weather. Ross is also undertaking a PhD at the London School of Hygiene and Tropical Medicine, which will aim to develop an validated tool which can be used to identify individuals at risk during a heat wave, so that early and effective public health action can be taken, which resonates a lot with my own research interests. So Ross will thus talk about his experience of working to prepare and respond to compound dry hot extreme events. Thank you so much for being with us today, Ross, and the floor is yours.
Great, thank you very much. So yes, my name is Ross Thompson. I am one of the scientists in the Extreme Events and Health Protection team at Public Health England, soon to be the UK Health Security Agency. So next slide. So today I'm going to give you a brief overview of some of the experiences that we've had in England over the past couple of years, and just give a few examples of where we've had to deal with multiple hazards occurring at the same time, and some of the lessons that have come out of that, which have influenced the direction of travel with our plans. And then finally, I'll just give a really quick example of a good piece of evidence around partnership working and the importance of that when dealing with multiple hazards. So next slide, please. So brief background, the Extreme Events and Health Protection team are the operational leads for the Heatwave Plan for England. And the Heatwave Plan is a collaborative plan, which is supported by the Department of Health and Social Care, the National Health Service, and the Local Government Association, and the Met Office in England. So the aim of the plan is to protect the population from the ill effects of high temperatures, and it does this by alerting people to the dangers of high temperatures and providing advice and guidance on how to reduce the harms. So as we've seen earlier today, actually there's suggested actions within the plan for commissioners of health and social care services, providers of those services, communities, voluntary sector, and individuals, and government organizations, both at the local level and the national level. Next click. So we also have associated with the plan public-facing resources like this Beat the Heat poster, and you can actually see we updated it due to the pandemic and the intersecting risks of COVID and heat. Next, please. And we also have professional specific resources available as well, all associated with the heatwave plan. Next, please. And the heatwave plan is underpinned by the heatwave alert system. And this is 5 levels and ranging from year-round action all the way up to emergency response. And I should just note that our team are also the operational leads for the cold weather plan for England, which is essentially the mirror image of the heatwave plan. So next slide, please. So I won't dwell on this too long. I think we had a pretty good overview of that at the start of the session. But just to say that we know that heat can affect the body in many ways, and it is mostly preventable. The epidemiology suggests that the main causes of death are cardiovascular disease and respiratory. Sorry if you click through. Next, please. And we also know that the impacts are observed within 0 to 24 hours, and we see this in the mortality. Next slide, please. So I thought I would give an example of some of the things that we've been seeing over recent years, and 2018 is a particularly good example of that. So in the winter 2018, we had Beast from the East in England, which was a blast of Siberian cold air coming in from the east, and it was the coldest temperatures in over a decade, and I think there was a red snow warning from the Met Office. But we also had to extend our cold weather alerting period. So next, please. And so you can see that only 2 weeks after that extended period, we had a warm spell in the middle of April, which was actually the warmest April day, I think on the 19th, ever recorded in the UK. Next, please. And the high temperatures continued into May, and particularly around the 2 May bank holidays, and where temperatures were in the high 20s Celsius. Next, please. And then we finally entered into the traditional heat health alert period at the 1st of June. And over this period, temperatures remained high and above average, but not quite hitting our alerting thresholds. Next, please. Up until the end of June. Next, please. And then from then until maybe the mid-July, our temperatures that we were observing were right around the alerting threshold. So you can see at the start of July, we were just over, so alerts were issued, and then from after that, temperatures were just below our alerting threshold. So we were on this knife edge over the whole period. So following, next slide, please. So following that, we had this period where it was actually quite significant heat. And I should just mention from May up until July, it was also extremely dry over this whole period. I think at one point in London in the southeast, I don't think there had been rain in over 2 months. And we also had to deal with lots of wildfires going on, some more fires. And during this period, we had to adjust some of the public health, public-facing advice that we were issuing, specifically around opening windows at night when the air is cooler outside to allow cooler air inside homes. Obviously, the smoke from the wildfires created air quality issues, so we had to shift the focus of some of our advice. Next slide, please. So this slide, I just wanted to highlight the fact that we are starting to see what the models have been telling us for a long time. So this is the number of heat health alerts within a given year. And we can see that there is this clear increasing trend. So I guess we can take this as a proxy for increasing temperatures, but just to note that we are seeing this in the alerts that we're issuing. Next slide, please. And then the question is, well, what does this mean about the impacts that we're seeing? So this is an updated chart from a study by Green et al. And they they looked at the excess mortality during the 2013 heat wave and compared that to previous years. And one of their conclusions was that following a period of settling in, embedding sort of the heat wave plan and the alerting system, which was introduced in 2004, that mortality seemed to reduce quite a bit. So 2013 was quite a while ago, so we've updated that, and we can see that from 2016 up to 19, there seemed to be this step change. Why? Not clear. It could be because there were more heat wave days, possibly. But then we also have this 2020 mortality, which was the highest we've actually seen in England. 2020, of course, is a different kettle of fish because we also were dealing with, in the middle of a pandemic, and we recognized early on that COVID and heat vulnerability, the vulnerability factors overlap quite a bit. So whether or not this was COVID amplifying the impacts that we saw is still unclear, but it's something that we're trying to unpick further. Next slide, please. So we know that the excess mortality during heat waves is really just the tip of the iceberg. So this chart is taken from an independent evaluation of the heat wave plan for England, which was carried out by colleagues at the London School of Hygiene and Tropical Medicine. Next, please. So this is the temperature mortality relationship, and we can see that risk of mortality in London, in this example, starts to increase at around 24 degrees and continues to increase as the temperature increases. Next, please. And the histogram below that shows us that actually there is quite a big proportion of days over a summer period where we are above that 24-degree temperature. Next, please. And then this red dotted line is our alerting threshold for London, which is 32 degrees. And what this bottom chart is showing us is the attributable fraction of heat-related mortality at the different temperatures. And really this is saying that by the time we get to our alerting threshold, we've actually already observed the majority of the burden on health. Next, please. So in other words, if our emergency response functions and actions were 100% effective, we'd only be avoiding a very small percentage of the overall health-related burden due to high temperatures. Next, please. But it's not just about heat. We know I mentioned Beast from the East at the beginning in 2018, and we know from the distribution of temperatures that we're seeing, again, as the models have told us, we're starting to see more extremes. Yes, more hot and extreme hot extremes, but cold is not going anywhere. So it's important that we remember that. Next, please. Likewise, flooding. Flooding doesn't happen in isolation. So this is an example from last winter where we had a level 3 cold weather alert issued. There was flooding alerts. We were also in the middle of a pandemic. So all of these factors coming together, and we had to think, how do we respond to all of this, which are occurring at the same time? And again, floods don't just happen in the winter, they happen in the summer, like we saw in Germany this summer. Next, please. And of course, 2018, if we remain with that, I mentioned was dry. So this is just a snapshot of sort of the conditions during 2018, just to highlight how dry it really was and how that contributed to the grass fires and more fires that were reported to PHE. I think it was something like 34 that were reported over the summer, which is quite a lot compared to previous years. Next, please. But there are also these emerging hazards. So thunderstorm-associated asthma epidemics have been reported in England and across the world. The most significant was in Melbourne, Australia in 2016, but we actually have seen them in England as well. So this is just a example from this summer past where we saw a spike. Next, please. in the asthma indicators, which were associated with forecast thunderstorms. So we're currently investigating this. So next slide, please. So with all of this in mind, and acknowledging that these hazards occur sometimes at the same time, we need to take a holistic approach to how we're actually responding to these and preparing for them. And so one of Public Health England's objectives under the National Adaptation Programme was around, or is around, developing a single adverse weather and health plan. So really bringing together the elements of the different hazard-specific plans and advice and guidance, because we know that they can interact and we need to be prepared for that. Next, please. So the core elements of this will be heat, cold, and flooding, because they are the main hazards that we face in England. But it's also important that we maintain our trying to understand how some of the emerging hazards might affect health and how we respond to those. Next, please. But one of the main things that we'll be trying to do with this new plan is expand the focus away from just emergency response and to really embed system-wide adaptation as a core function across the entire system. And that requires partnership working. Housing will affect health, transport policies will affect health. So how do we engage across the system to ensure that health is considered at the core of all of that, and that we get the biggest bang for our buck, essentially, with adaptation. So next slide. So this is my final slide, and it's just an example of a good example, I think, of that sort of partnership working. So the Natural Hazards Partnership is a partnership across all these different organizations you can see on the slide, and they all have a role in either monitoring, alerting, or responding to different types of hazards. And what the Natural Hazard Partnership does is collate all of the different daily hazard assessments into one piece of information. So next, please. And you can see that. So in this example, there was a amber, a level 3 cold weather alert. There was a yellow flood alert. So you can see all of these different things are going on at once. Next slide, please. And this Natural Hazards Partnership is a really good example of how all of these desperate risks can be brought together into one piece of information and sent out. So I think I'll stop there now that I'm out of time. But yeah, thank you very much.
Thank you so much for such an insightful presentation and for giving real-life examples of preparedness and response. And I'm really glad that we are here today addressing this important topic with such great speakers and audience participation. What I want to do now is to take a moment and integrate the audience perspectives, and thank you so much for adding your answers. I encourage the audience to please keep adding your perspectives, and I'm very much appreciating the interaction with the Slido questions and also the Q&A box and hearing what you have to say. So if we could have a look at the inputs in Slido and have a, yes, thank you, and have a real understanding of the things that you are thinking of when you're trying to describe dry, hot, compound extreme events. So we're seeing there things such as intensifying, stressful, social justice, risk to health, water scarcity, vulnerability, and also issues with justice. So it's really good to see your thoughts on this topic. Can we have a look at the next question, please? And yeah, so in this example, I can't see the screen very well. Yes, in terms of the responses, if you're aware, I think yes, not a lot of people are aware of. That we need to improve multi-hazards or compound dry hot extreme events. And in terms of the solutions, can we have a look? I think it's not the next one. Yes, solutions. Yes, there are lots of inputs on that in terms of heat event response and planning, also municipal heat. Yeah, the UK heat wave warnings. So now I think what I would like to do is also to bring to the floor our speakers and bring some of the questions in the Q&A that our audience would like to hear from you. So maybe the first one, if we could have our views on what is the mechanism for fires increasing risk of heat waves. And possibly I would like to welcome Samuel, which has just joined us live. So thank you very much, Samuel, for being with us today. And could you give us some insights on how this can occur?
Okay, thank you, Raquel. Yeah, I'm sorry that I just came from teaching, but luckily I can join you guys. So basically, if you ask me what kind of a factor that can increase the risk of a fire, and first, of course, like what I explained it to you, the temperature, that's the one, and the second also the condition of the soil. So it's not only and after that the fuel, for example, like the forest, yeah, or the plant. Some plants can easily be burned, but some plants can be like more resistant to fires. So there are so many components, but at least temperature, soil conditions, and the fuel or the plant itself. That's my opinion. And after that, of course, the non-technical factor, like if someone burn or someone smoke cigarette and just throw away, it also can be burn the forest. And this is the problem that we cannot identify until now. I mean, we cannot forecast this.
Would any of you, Andrew or Ross, like to answer?
I don't think I'm qualified to answer that.
Yep, I have nothing to add. I think Samuel, that answer was excellent.
So if you could go to another question, which relates to which sector do you think compound heatwave and drought events impact the most?
Well, I can talk about the health sector. And I think the example that I gave in terms of 2018 just highlights sort of the issue that we are likely to face more and more often. So I think 2018 was the first time we had to really consider our public health advice, public-facing advice, due to other factors that were going on. And since then, it appears that every time we've had an alert, whether it's cold, heat, there have been other things going on that we've needed to consider and adapt to. So that's just an example of the health sector, but I'm sure that other sectors are having to deal with the same thing as, these extreme events are happening more frequently.
Yeah, I could add something to that. So I think in terms of most impact, I'm not sure I could answer that. Something that comes to mind is thinking about the metrics used to assess the degree to which different sectors are impacted by dry hot extremes. And I'm thinking that some sectors may have a very quantitative, I'm not sure if that's the right word, approach to looking at, let's say, like economic stress or I don't know, just financial implications of dry hot events. And I don't think that's really the best way to assess impact. There are various sectors that are impacted directly and indirectly. And many times, as we see with extreme events, and especially with compound events, the traditionally underserved populations, or the most vulnerable populations, or the ones ignored in society, many times the stress on these groups is not adequately assessed when we're talking about impact. And I mean, we've seen this recently. For an example, here in New York City, where we saw devastating flash floods a few weeks ago. The event was largely forgotten in the next couple of days, even though the death toll was almost the same as Superstorm Sandy a few years ago, which led the city to review and revise many different policies. We're in areas. Sorry about that. I think
just having some issues with the connection.
Okay. Well, I think my point. I think hopefully my point was made. Thank you.
Yes, thank you very much. So maybe one last question would be regarding. So one of the four goals for the COP26 is adaptation. And action on adaptation, including urgently adapting to protect those communities and individuals that are most vulnerable. So how do you think we could see this being achieved during COP26?
So I'll jump in there. Again, from sort of the health perspective, I think health is affected by pretty much everything in that's going on in the world. And in terms of policy, I think it's quite difficult for health to affect policy in lots of different areas. I mentioned housing. We know that with heat, the buildings we're in modify the temperatures that we're exposed to greatly, and we have housing that are built because there's other issues. There's a housing crisis, and we want to build fast. But whether or not the overheating is considered within those kind of planning policies, that could lead to overheating. And we have cold weather. We're sort of retrofitting our houses to make sure that we're reducing the amount of carbon used to heat our homes, but that may inadvertently increase the risk of overheating in our homes. So it's important to have a cohesive policy and a holistic view of what's going on. And I think from a health perspective, we need to get health within all policies, really. We need to be at the table. We need to be discussing with our housing colleagues. We need to be discussing everything with our transport colleagues to understand make sure that everyone understands the co-benefits of all of this. It's easier said than done, and we are trying to do that within Public Health England and the Health Security Agency going forward.
Samuel, could you share your insights?
Well, for my opinion, in terms of only in the top level, let's say in the government, maybe we should also consider from the bottom-up approach, from the citizens, because people usually is the one who really feel the impact. So we can also ask for the feedback from them, So we have the adaptation strategy this time. But after that, when they implement that, what they feel, do you think that we really can reduce the impact? Because sometimes the government, we can just easily say, we reduce the impact by doing this. But maybe the citizen will say, oh, we don't feel it, or maybe something like that. So maybe also nice to have a vice versa, bottom-up approach, asking feedback from the people.
Andrew.
Yeah, I would like to see more substantial integration of like the people's perspective, I guess, and that means a lot more than just a seat at the table. I mean, I think that's something that we've dealt with in this movement from early warning systems into anticipatory action systems. Just because you have voices doesn't mean they're actually being heard or prioritized. And I think there is, unfortunately, a lot of that in disaster risk reduction, where it's like we need to talk to the local community. And then you get a couple people in the room, and then they speak, and notes are taken, and then you kind of check the box and you do something else. And I think that we're at a crossroads where we have to rethink the way that we integrate voices and not.
Sorry about that. We're having a connection problem. So I think our time is up. I would really like to thank everyone, all the speakers and all the audience for your insightful contributions to the session into better understanding the enablers and barriers to preparedness and response to compound dry, hot, extreme events. And lastly, I would just like to say thank you so much, everyone. We should continue this conversation. It's a really important topic, and I hope you'll hear more from us in the future. And I have in my last slide my contact details. So we weren't able to address all the audience questions. I will try and put those questions to our speakers and share the answers with you. So thank you so much again for being here. I hope you have enjoyed, and thank you very much. Goodbye.